This is Naga Lakshmi Devi, Assistant Professor, Department of Freshman Engineering, IARE, Hyderabad, Telangana. Now today topic is continuous random variable. A random variable x which can take values continuously, that is which takes all possible values in a given interval, is called a continuous random variable. A continuous random variable is a random variable that can be measured to any desired degree of accuracy. For example, we can consider the heights, weights, age of individuals, temperature, some etc. For example, we can choose any number 0, 1 in between values. It will be goes on 0.1, 0.2, 0.3 like that. It is continuous process. Then this process is called continuous random variables. Now the probability distribution functions. This is the there are some properties are there. First of all, what is the probability distribution function? Let capital X is a random variable, be the random variable, then the function fx of x equal to p of x less than or equal to x. The random variable capital X is less than to x, that is minus infinity less than x less than infinity, is called the distribution function of x. Now the properties here, it will be fixed on minus infinity to plus infinity. Now the properties of distribution function. If f is the distribution function of a random variable x, and if a less than b, we can choose the boundary values, that is a and b, then the first point is p of a less than x less than or equal to b. Now the function of distribution is f of b minus f of a. That is the first one. And next one, p of a less than or equal to x less than or equal to b. That implies p of x equal to a plus f of b minus f of a. Here f of b is a boundary value, ending value, and a is the starting value. And next, p of a less than x less than b, that equal to minus p of x equal to a plus p of b minus p of a. And next one, fourth one, p of a less than or equal to x less than or equal to b, that equal to p of x equal to a minus p of x equal to b, that equal, and f of b minus f of a. These are the four conditions we are applying by using the problems. We are using these four conditions. Next, fifth one, here f of minus infinity, that means the function of minus infinity is always 0. Otherwise, the limit extends to infinity, f of x equal to 0. And f of infinity equal to 1. The limit extends to infinity, f of x equal to 1. In this two also we are using in problems. Probability distributions. Probability distributions, there are two types. First one, discrete probability distribution, and second one, continuous probability distribution. First one, discrete probability distribution, probability mass function. It is for only by using up to nth derivative, nth term. Suppose x is a discrete random variable taking at most infinite number of values, but we are choosing x1, x2 up to so on xn, then the probability of each possible outcome x1, we associate a number pi. Pi is equal to pi of xi or p of xi. We can write it in any one. Is called the probability of xi. This must be satisfies the following conditions. Here we are using pi or pi of xi or p of xi. Any one. We are using this one. This is the first property. P of xi is always greater than 0 for all values of 1. Now, second one, summation of p of xi equal to 1, or sometimes we are using pi equal to 1, are called the probability mass function of the random variable x. The set of p of xi where I equal to 1 to up to so on n is called the discrete probability distribution of the discrete random variable of x. In continuous also same we are using this one, but in the we are using integral. Here we are using summation. Now, last one, that is probability density function. Fx of x equal to fx of x is defined as the derivative of the probability distribution, that is fx of x is that is here x is random variable, is equal to derivative of fx of x. That means f dash of x. That means f dash of x. This is the first example of the discrete random variables. When Two dice are thrown. Let x be the random variable representing the sum of number of points on throwing two unbiased dice. Here we are using two dice. Throwing the sum is the number. The two dice are unbiased dice. The solution is, for example, in two dice we are calculating like this: 1 1, 1 2, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. And next one we are starts with 2, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, etc. Like 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Now total elements are 36. Here they are asking sum of the numbers. Here the sum of first two numbers are 1 plus 1 is equal to 2. How many sets are there? Only one set. The sum of another one. The sum of these two are 3. That means 3. How many sets are there? It is 2. And next 3 plus 1 it is 4. And this is also 4 and this is also 4. How many changes are there? This is, how many are there? 3. Next 4. Here it is 5. The sum is, the two elements of sum is 5. The total elements are 1, 2, 3, 4. 4. Similarly, remaining also. Here it is total is 6. The how many terms are there? 1, 2, 3, 4, 5. 5 terms. Next, here the total is 7. The total is 7. The total sum of the 2 points are the 7. How many are there? 1, 2, 3, 4, 5, 6. Next series is 7. 8. Next 8. The total is 8. How many terms are there? 1, 2, 3, 4, 5. 5 are there. Next, it is 9. The sum of the total set of elements, the sum is 9. It is, how many are there? It is 4. Next 10. It is 3. It is 3. Next 11. It is only 2. Only 12 is only 1. This one. Next. The sum is 2. That the probability of x equal to 2. How many are there? X equal to 2. Only 1. Only 1 is there. That's why we are considering 1 by 36. Only one chance is there. That is 1 comma 1. And the sum is 3. The sum is 3. How many are there? 2 chances are there. 2 by 36. The sum is 4. The sum is 4. How many are there? Here 3 chances are there. That is 3 by 36. Similarly, we are continuing that process up to sum equal to 12. That is p equal to p equal to 12. Then we get how many are there? That is last one, 1 by 36. 1 by 36. Now the probability distribution function. That is, this is the probability distribution where starts with 2. The sum is 2. Starts with 2 onwards. 2 to up to 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The first one, 1 by 2 means we get 1 by 36. 3 means 2 by 36. 4 means 3 by 36. Continuing this process up to 12 means 1 by 36. This is the probability distribution table. This is complete. This table is called probability distribution table. This is the discrete random variable example. Next, cumulative distribution function. F of x of a discrete random variable x with a probability distribution function f of x is equal to p of x less than or equal to x. The random variable capital X is less than or equal to small x. That is summation of t less than or equal to x f of t for minus infinity to minus infinity less than x less than plus infinity. That means here t is some in between of the value, the random variable in between of the value. That is small t. This is called cumulative distribution function. Cumulative means we are accumulating step by step, we are adding the cumulative distributions. Next one, continuous probability distribution. Distributions are two types. First one is discrete. Already it is completed. Next one is continuous probability distribution. A function with values f of x defined over the set of all real numbers is called a probability density function of the continuous random variable x if p of a less than or equal to x less than or equal to b is equal to integral a to b f of x dx. This is also written as f of b minus f of a. Always we are using this function. Next, P of minus infinity less than x less than infinity, that is integral minus infinity to infinity f of x dx. The given function, maybe the limits are a to b are some 10 to 15, some 18 to 20 like this. We are arranging this one. If the given function is minus infinity to infinity, we can choose this one. The properties of continuous probability distributions. A function can serve as a probability density function of a continuous random variable x if its values of f of x satisfy the following conditions. First one, f of x greater than or equal to 0, that is minus infinity less than x less than infinity. In second condition is integral minus infinity to infinity f of x dx equal to 1. In earlier, discrete probability distribution is summation of p of x equal to 1. Here it is continuous is integral minus infinity to infinity f of x dx equal to 1. Similarly, in their cumulative distribution is the discrete probability distribution. In continuous also, cumulative distribution function is there. That is, if x is a continuous random variable and f of x is its probability density function, that is, f of x equal to p of x less than or equal to x is equal to integral minus infinity to x f of x dx. That means, if the function is integral minus infinity to infinity, the in-between value we are choosing either x. Here we are choosing integral minus infinity to x. Otherwise, sometimes we are using x to infinity also. In cumulative distribution means we are arranging in-between value also. We are calculating in-between value also. That is the cumulative distribution function. Mathematical expectation, E. Here mathematical expectation of discrete random variables, it is represented by capital E. If x is a random variable which can assume any one of the values x1, x2 up to so on xn with respect to the probabilities p1, p2 up to so on pn, corresponding values, we are considering completely corresponding values, then the mathematical expectation, it is denoted by E of x. It is denoted by E of x. E is defined as the sum of the products of the different values of x. Sum of the products of the different values of x and corresponding probabilities. Sum of the products of the different values. That means p1, x1, p2, x2 like this. The corresponding probabilities. Corresponding probabilities means p1, x1, p2 respectively terms for corresponding values. Therefore, E of x equal to the formula is p1, x1 plus p2, x2 plus p3, x3 plus up to so on pn, xn. This can be simply, we can write it as summation I equal to 1 to n pi xi. We know already the discrete random variable, the property is pi is equal to always 1. Summation of pi equal to 1. Otherwise, summation of pi of x or summation of p of xi is equal to 1. Okay. Similarly, in generally, we can write it as E of x power r equal to summation I equal to 1 to n pi of xi power r. Here x is there, we get x1, x2 up to so on xi. Here x power r, it is x power r. For example, here x square is there, pi xi square. We can write it as like this. This is the final formula of the mathematical expectation. This mathematical expectation is nothing but mean mu. The next topic is mean mu. Expectation is equal to mean. Both are same. That is how we can say it as same. Mean mu equal to E of x is equal to, in a frequency distribution we are using, this is the probability distribution table. X is the random variables, f is the frequencies, x1, x2 up to so on xn are the random variables, f1, f2, f3 up to so on fn are frequencies. Here x bar is the mean. The formula of x bar equal to summation of fi xi by summation of fi. Sum of the observations by total number of observations. Sum of the observations f1 x1 by total number of observations, we can write it as the frequency is also written as capital N. Otherwise, summation of fi, that is our choice. fi xi by n plus f1 x1 by n plus f2 x2 by n plus f3 x3 by n plus up to so on fn xn by n. This is also written as f1 by n, we can be written as p1, probability of function 1 into x1 plus p2 x2 plus p3 x3 plus up to so on pn. How we can write p means f by n, f1 by n, the first function by total number of observation is equal to p1. Then similarly remaining also. Now second one similarly same, f2 by n up to so on, pn by n is also same, fn by n is nothing but pn, into xn, that equal to summation I equal to 1 to n pi xi. Same expectation is also same formula, summation of pi xi. Here also the mean is summation of pi xi, summation of I equal to 1 to n pi xi is equal to mean mu. Therefore, mean mu equal to Fx equal to Fx. Mathematical expectation of a random variable is nothing but its mean. This is the mean. Next, variance. The next topic is variance. Variance is nothing but V of x is equal to sigma square. It is denoted by simply sigma square. E is equal to E of x square minus E of x whole square. This is the fixed formula. The proof of the variance is how we get this one. This is the proof. Variance is the expectation of the squared deviation of the random variable. Expectation of the squared deviation of the random variable from its mean. Variance of the probability distribution of a random variable x is the mathematical expectation of, that means E of. This is the total formula of the variance. This can be written as already we know E of x equal to summation of I equal to 1 to n pi xi. Here x means xi. Here we get the x minus E of x whole square means we are writing as xi minus xi whole square. Next one. This is the proof. Here we can write it as E of x is nothing but mean mu. This is nothing but mean mu. That's why we are simply writing it as pi into xi minus mu whole square. That is the condition. Xi minus mu whole square. Xi minus mu whole square can be written as a minus b whole square. That means a square minus b square, a square minus 2ab plus b square. Similarly, here it is xi square minus 2 mu xi plus mu square and pi into pi. Now we are multiplying each and every term. Pi into xi square minus 2 mu xi into pi plus mu square, pi into mu square. Here we know summation of pi equal to 1. That means this part is 1. And next pi into xi square. This is also written as here f x equal to summation of I equal to 1 to n pi xi. Similarly, f x square nothing but summation of I equal to 1 to n pi xi square. Here it is same. That's why we simply write it as E of x square minus 2 mu as it is. Pi xi is already we know E of x. Simply write it as it is E of x. E of x is nothing but mu. 2 mu into mu, that is 2 mu square, plus already this one is 1. Remaining is mu square plus mu square. E of x square minus 2 mu square plus mu square. Overall, E of x square minus mu square. Already we know mu is nothing but E of x. Mu square is nothing but E of x whole square. This is the final proof. Variance is nothing but V of x. Variance of x equal to sigma square equal to E of x square minus E of x whole square. This is the variance. Similarly, next is standard deviation. Standard deviation is a positive square root of the variance. Simply we write it as sigma equal to square root of V of x. That's all. If the value of V of x is 25, that the sigma value equal to 5. Simply write it as like that. Some theorems are there by using mean and variance. For the first theorem is, if x is a random variable and k is a constant, then E of x plus k equal to E of x plus k. That means we are choosing E of x plus k equal to, now what is the mean formula? That is summation I equal to 1 to n. What is the mean of the formula? E of x equal to summation I equal to 1 to n pi into xi. Similarly, here we are using like that, pi into xi plus k. That equal to summation. We are splitting into two parts, pi xi plus summation I equal to 1 to n pi into k. Here k is nothing but constant and x is random variable. Summation I equal to 1 to n pi xi plus k into summation of I equal to 1 to n pi. Already we know summation of I equal to 1 to n pi is 1. We know that this is nothing but 1. We know. And this is nothing but E of x. That equal to E of x plus k into 1. That is E of x plus k. Then our first condition is satisfied. E of x plus k equal to E of x plus k equal to E of x plus k equal to E of x plus k. The first theorem is completed by using mean of random variables, mean of discrete random variables. That is the first condition. Now second theorem, if x is a random variable and it is and a and b are two constants, then E of ax plus b equal to a into E of x plus b. In that is also by using above theorem. That is also simple one. That is E of ax plus b is equal to, our mean formula is summation of I equal to 1 to n pi into ax plus b. Now split into subparts. Summation I equal to 1 to n pi a into x, it is xi plus summation I equal to 1 to n pi into b. Now a is a constant. By using theorem 1, a is a constant, eliminating outside, summation I equal to 1 to n pi xi plus b into summation I equal to 1 to n pi. We know the property. Here this is 1. This is nothing but E of x, that equal to a into E of x plus b into, this is nothing but 1. Therefore, a into E of x plus b. Therefore, E of ax plus b is equal to a into E of x plus b. That is the second theorem. The third one is, if x is a random variable, then variance of ax plus b is equal to a square into variance of x. Here variance of any constant is 0. Simply we are using that condition. Simply we are solving this is in variance formula, by using variance formula. What is the variance? Variance is nothing but E of x square minus E of x whole square. I am using that formula. Variance of x is equal to E of x square minus E of x whole square. Now first of all, we are choosing V of ax plus b. Ax plus b. This is the random variable. We are using a and b, two are constants. Now the variance of this one is V of ax plus V of b. We know variance of any constant is nothing but 0. This total part is 0. This total part is 0. That means V of ax. V of ax is nothing but E of x square, ax square minus of E of ax whole square. E of ax whole square. Then this is also written as E of a square x square minus E of, this is whole square. That means E of ax into E of ax. X square can be written as x into x like this. Here it is a square into E of x square. If this is by using first theorem, we get the a square in outside. That is a square into E of x square minus a into E of x by using first theorem. Here a into E of x. This is also first theorem. That means a square into E of x square minus a into a square into E of x whole square. In common with the a square, that is E of x square minus E of x whole square. This is nothing but this total, this formula is nothing but V of x. That is V of x. Henceforth, V of ax plus b is equal to a square into V of x. This is the another theorem by using variance. Total, these two are using means, and here we are using variance. Here we are using means, and here we are using variance theorem. These are the standard theorems. Next, discrete random variables. First problem. A random variable x has the following probability function. This is the probability function table. X and p of x is the probability functions. 0, 1, 2 up to so on n, 1 to so up to so on 7. Here the probability values are 0, k, 2k, 2k, 3k, k square, 2k square plus 2k square into last one is 7k square plus k. Find the value of k. Find the value of all k's, and that means only k. And second one, evaluate p of x less than 6. Next one, p of x greater than or equal to 6. Next one, p of 0 less than or equal to x less than or equal to 4. And another one, p of 0 less than x less than 5. Here total 0, it is lies between 0 to 7 in between. We are the solving process is also 0 to 6, greater than less than 6 values, greater than or equal to 6 values, 0 and 4 in between values, 0 and 4 without 0 and 4 in between values. Okay, we are finding all these things. And next, determine the distribution function of x. Distribution function x means the table of this one, distribution function. Already we see earlier problem that we can solve like that. And another one is mean. Mean means E of x or mu. Variance V of x, standard deviation sigma. And finally, if p of x less than or equal to k is greater than 1 by 2, that is nothing but 0.5. Find the minimum value of k. Here, which one is minimum? We are calculating that one. This is the complete problem. How many are there? First, find the k value and less than 6 values. How many probabilities are there? Less than 6 and greater than or equal to 6. Greater than or equal to 6 means 0 to 6. Less than 6 means 0, 1, 2, 3 up to so on 5 only. Less than 6 only. That means below 6. Greater than or equal to 6 means 0 to 6 also. Next, 0, 4 in between values, 0 including 0 and 4 also. 0, 1, 2, 3, 4. Here, next one, 0 to 5. That means 0, 5. We are eliminating that 2. Remaining means 1, 2, 3, 4 only. We are calculating like this. These are the functions. First one, how to calculate the find k value. Here we know the summation of pi equal to 1. We are using that probability function since summation of I equal to 0 to 7. How many probabilities are there? The random variables 0 to 7. That's why we are using the random variables I equal to 0 to 7. Pi equal to 1. That means P0 plus P1 plus P2 plus P3 plus P4 P5 plus P5 plus P6 plus P7 is nothing but 1. First one, P0 value is 1. Here this is P0, P1, P2, P3, P4, P5, P6 and finally this is P7. Similarly, this is X0. In next method we are using this one also. That's why I am writing like this. X2, X3, X4, X5, X6 and finally this is X7. Now P0 value is 0, P1 value k, P2 value 2k, P3 value 2k, P4 value 3k, P5 value k square, P6 value 2k square, P7 value 7k square plus k. The total is nothing but 1. Now this is 10k square plus 9k minus 1 is equal to 0. Here k, the k value, here using fractions we get k value equal to, first one is minus 1 and another one is 0.1. The probability always lies between 0 and 1. That's why here we are not choosing k value is not equal to 1. We are not taking the minus 1 value. Just we are considering k value is 0.1. Always we are considering in between of 0 and 1 values only. That's why k equal to 0.1. We are choosing k value is only 0.1. Now first point is, second one in first part is p of x less than 6. Less than 6 means x equal to p of x equal to probability of x equal to 0 plus probability of x equal to 1, probability of x equal to 2 up to so on, probability of p of x equal to 5. Now first one, 0 value is 0. Here it is 0 value is 0. Next p naught value is 0, p1 value is k, like that. Here applying all the values 0, k, 2k, 2k plus 3k plus k square. Up to this is p of x equal to 5 value. Now the summation is, the total sum is k square plus 8k. We know already in first step we are calculating a k value is 0.1. Substituting that k value in 0 in this equation, we get 0.81. Now the probability of x less than 6 value is 0.81. And next one is p of x greater than or equal to 6. That means 1, 0, 1, 2, 3, 4, 5, 6 up to 6. Otherwise we are simply write it as p of x. P of x, here they are asking greater than or equal to 6 means 1 minus p of x less than 6. That means p of x greater than or equal to 6 means p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 plus up to so on, p of x equal to 5 plus p of x equal to 6 is nothing but 1. Then remaining means here 1 minus we can write it as 1 minus p of x less than 6. Here simply here stop here only. That is 1 minus p of x less than 6 only. That is the condition. In that part we are using that one. 1 minus p of x less than 6. Already we are calculating p of x less than 6 in earlier condition, that is 0.81. We get 0.89. Next, 0 less than or equal p of probability of 0 less than or equal to x less than or equal to 4 means 0, 1, 2, 3, 4. Probability of 0, 1, 2, 3, 4. Sum of the probabilities of 0, 1, 2, 3, 4. Then first 0, 1, k plus 2k, 2k plus 3k. That is total 8k. Already k value is 0.1. It is 0.8. That is 0.8. Next, p of x, next part is 0, p of 0 less than x less than 5. In between of 0 and 5 means 1, 2, 3, 4 only. The sum of the total values is equal to k plus 2k plus 2k plus 3k equal to 8k. Again it is k value 0.1, that is 0.8. And next topic is, next one is determine the probability distribution function of x. They are asking the table, individual table, that is 0, cumulative distribution. Here using cumulative distribution, 0, k, 0 plus k. Next k plus 2k, that is 3k. Next 3k plus k plus 2k plus 3k plus 2k, that is 5k. Next 5k plus 3k, 8k. And that means here it is 0 plus k, k plus 2k, 3k, 3k plus 2k, 5k, 5k plus 3k, 8k, 8k plus k square, 8k plus k square plus 8k plus 2k square, that means 3k square plus 7k square plus k, that is 10k square plus 9k. Here it is, we are substituting simply 10k square into, this is k square means 0.1 whole square plus 9 into k value is 0.1. It is, we get 1. Compulsory we can check it once. Compulsory we need that one. That's why I am using here also that one. 0 is 0. First one, 1 x naught value 0. It is p naught value 0. X1 value is 1. K1 value is, k means here it is 0.1. X2 value is 2. This is 2k, that is 0.3. Continues this process. Here last one, k7 equal to 1. Okay, p7 equal to 1. Compulsory, this is the probability, sum of the probabilities, summation of pi equal to 1. That's why here compulsory we get 1 value. If the value is not in 1, then your problem is mistake. Again, cross check the each and every term. Next one, mean of the total, mean of this problem. That is mean equal to summation I equal to 0 to 7 pi xi. Mean formula is pi into xi. Now pi xi means p naught x naught, that equal to p naught x naught plus P1 x1 plus P2 x2 plus P3 x3 plus P4 x4 plus P5 x5 plus P6 x6 plus P7 x7. That means P0 value 0, x0 value 0 plus P1 value k into 1 into k, otherwise k into 1 plus 2k into 2 plus 2k into 3, next plus 3k into 4 plus k square into 5 plus 2k square into 6 plus last one 7k square plus k into 7. The total is 66k square plus 30k, that equal to here k value is 0.1. We are substituting that value, we get 3.66 is the mean of this problem. Okay, next one, variance. Variance formula is summation I equal to 0 to 7 pi xi square minus mu square. We know this one. This is nothing but e of x square minus e of x whole square. This is, we know the e of x is mu square. E of x square can be written as pi into xi square. Simply we are writing like this. Now, pi into xi square, that means p0 x0 square plus p1 x1 square plus up to so on plus p7 x7 square, that is this part, minus mu already we know, that is 3.66 is the mu value whole square. That this total value is 440 k square plus 124k minus 3.66 whole square. The total is 3.40. This is the variance. Up to 2 decimals is enough. It is a extra. Okay. Now standard deviation is sigma is nothing but square root of v of x, that equal to 1.84. That is 1.84. That is the standard deviation of this problem. Next, finally, last one is important one. If p of x less than or equal to k, that is greater than 1 by 2, find the minimum value of k. Here, we need k value. That k value is always, in this problem, always 0.5 above 0.5. The 1 by 2 is nothing but 0.5. We can stop in there only. 0.5 above, we can consider in stop. That is the minimum value of the k. Then, finally, we can choose if p of x less than or equal to k is greater than 1 by 2, that is 0.5. First of all, p of x less than or equal to 0, that is nothing but p of x equal to 0, that value is 0 in given table. Now, p of x less than or equal to 1 means p of x equal to 0 plus p of x equal to 1. Cumulative distribution. Here we are using cumulative. Then 0 plus 1, that means 0 plus k, that equal to 0.1. This is second one. P of x less than or equal to means 0 plus 1 plus 2. Probability of 0 plus 1 plus 2, that equal to 0 plus k plus 2k. That is total. I think this is 3k. That is k value is 0.1. It is 3.k. 0.3. Next, p of x less than or equal to 3. 0 plus 1 plus 2 plus 3. That is 5k. That is 0.5. Up to here it is enough. If the given condition is equal to 0.5, we can stop here only. But they are asking greater than 0.5. Then we can move the next step also. That is p of x less than or equal to 4. That is p of x equal to 0 plus p of x equal to 1, p of x equal to 2, p of x equal to 4, 3, p of x equal to 4. Then that equal to 8k, that equal to 0.8. This is the minimum of the value. In which step we get the above 0.5, that is k equal to 4. That step is k equal to 4. That's why, therefore, we can choose the minimum value of k equal to 4. That's all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.